Hello, okay, this is probably going to be our last lecture in the entire course. Okay, I'm going to wrap up the Chapter 7 homework. We're looking at 6, 7, 9, and 10. These all have to do with measurement of risk as calculated under the capital asset pricing model of Dr. Markowitz. And then we're looking at a couple of changes. So let's start with problem number 6. The risk-free rate is 2%. The market return, in other words, a market portfolio, a portfolio containing one share of every individual stock in an indexed market like the New York Stock Exchange. Okay, the market return is 9%. Risk-free rate, of course, of 2% indicates the return on a short-term instrument of the U.S. government, the money market. It's called the U.S. T-bill, Treasury bill. Okay, and the third thing you need to know for an individual stock you're considering is the beta, and the beta coefficient, a measure of volatility against the market, is 1.27. What rate of return would you expect? Okay, I took the liberty of writing the master formula right up here. K sub S is what we're trying to find, the risk-adjusted rate of return. R sub RF is the risk-free rate, that's the 2% on the T-bill. And the market return, we said, was, what, 9%? And the beta that we're considering for this initial stock is 1.27%. It's very simple plug and play. What I'm going to recommend is that you always write in your known data over here. So let's start with the risk-free rate. Okay, then we'll follow that up with the expected return on the market portfolio. Okay, and finally the beta of your stock, the stock that you're considering and therefore want K sub S of. Okay, poor diction, poor English, but you know what I mean. Okay, the risk-free rate of return is 2%. The expected rate of return on the market is 9%. In this example, all of this was given in problem number 6, and the beta on your particular stock is 1.27. Okay, plug those numbers in, and it's really quite easy. We're going to find K sub S. So let's say K sub S. And that's going to be equal to, let's try that again, K sub S is going to be equal to, in this case, it's going to be 2%, 0.02, okay, plus a risk premium. The whole thing is going to be noted as, and I'll use brackets here. Okay. Inside, it's going to be 9%, okay, 0.09, minus 0.02, and we multiply that entire thing by the beta, which in this case is 1.27, and I think we've got it all. Yes, there it is. I used the brackets there just to help us remember the order of operations, okay? So once again, that's going to end up with, let's see, I think we can do this whole thing right now. Yes, sure we can. Okay, so I'm going to take 0.02, I'm going to add to that, parens, 0.09 minus 0.02, parens, multiplied by 1.27, parens, and I get 0.11. All right, I'm just going to multiply that by 100. Let's try that again. Having a bad typing night. Okay, let's take that number times 100. And I get 10.89%. Okay? All right, that is my answer. Okay, it's that easy. Now, if that number had been 9% or less, I would have known I did something wrong, because that beta of 1.227 tells me this stock is more responsive than the market. Therefore, it would have to return a number greater than the 9% that the market is returning. Okay? All right, next we'll do problem number 7. All right, and let's just grab all of our numbers and use the same formulas. I'm going to do a copy and a paste, just like that. This time, okay, it says the same data as in 6 above, but this time the only thing that changes is your beta. So all this stays the same except the beta, and this time around the beta is going to change to 0.47. All right, 0.47, there we are. Now this time we know that the result, rather, the K sub S is going to be it's going to have to be rather less than 9%, because your stock is less volatile than the market. Therefore, we won't expect as high a return as the market, the price of playing it safer. So the only thing I'm going to do is change that 1.27 to 0.47, just like that. All right, and we'll change up the math as well. That last factor becomes 0.47. My answer is 5.29%. Yes, it is less than 9%. Okay? Once again, I solved the equation, and then I multiply by 100 because I want to see my result as a percentage. All right. Next, we'll do problem number 9, I think I asked you to do. If you took it on yourself to try problem number 8. Problem number 8 said the stock, under the same conditions as number 6, has a perfect market beta of 1. What would the expected rate of return be? It's going to be exactly the same as the market. If your stock is doing exactly what the market's doing, then the math will give you 9%. It's got to. Okay, I consider that very obvious, and therefore I didn't ask you to do number 8, but give it some thought, okay? Number 9, same conditions as in number 6. What would happen to your ERR if inflation were to decrease by 5%? Okay, so let's go back and recapture all this data, and we'll play with it. Okay, bear with me 1 second. Copy, and put it right there. There we are. Okay, now we know that inflation is going to change. Inflation is going to decrease by 5%. Okay? Decreases by, what did I say, 0.5%? Make sure I've got my numbers right here, friends. 0.5%, half a percent. Okay, so we're going to use the same equation, but we're going to say, well, what factors are affected by a change in inflation? Okay, we know that the risk-free rate is affected. T-bills, rather, do have inflation in them. And the market return has inflation in it as well. So both of these factors would be affected by that change. So instead of 2%, subtract 0.5%, okay, that didn't work out well. That would be 1.5%. There we are. Okay, 9% is not going to be 9% anymore. It's going to drop to 8.5%. Okay? So I shaved half a percent off both of those numbers. What is the beta of my stock? I'm continuing to use 1.27 as my beta because I reset this to problem number 6. So I come down here and modify my math so that it's now going to read, instead of 0.02, it's going to say 1.5%. Okay? Instead of 9%, my market return will be 8.5%. And once again, my risk-free rate is 1.5%. So I change every instance in which a number was affected by a decrease in inflation. So that's my new and improved equation. Let's math it out and see what we get. 0.015 plus parens 0.085 minus 0.015 parens multiplied by my beta of 1.27. And this time, my number becomes 10.39%. That is my answer. And last but not least, I'm going to say, let's do problem number 10. So I'm going to grab all of the same data. Okay, this is problem number 10. Place it right here. Okay, and this time, instead of inflation decreasing, inflation stays the same, but risk, as demanded of the market, is going to ease up by 0.8%. Okay, so market risk decreases by 0.8%. Okay. All right, what changes? the risk-free rate. Okay, the risk-free rate is now reset to 2%. The expected return on the market, let's hold off on that one. My beta is going to stay at 1.27. Okay, the only factor that's going to change this time around is the expected return on the market. Instead of 9%, market risk, not inflation now, but market risk only is going to decrease by 8%. So instead of 9%, that's going to be 8.2%. And that's it. So now what I'm going to do is recast my equation. All right, I'm going to change that back to 2% because my inflation rate is where it originally was. This number becomes 0.082. Out here, I reset my inflation to 0.02. And if I did this right, let's see what we get. Okay, I want to get 0.02 plus parens 0.082 minus 0.02 times 1.27 beta, and I get something does not look right to me. Yes, 0.082, 0.02, 1.27. Okay, 10.39. Hold on just 1 minute. Let me check my math one more time. It's 102. Okay. 0.082. Okay, that does not look right to me. It should have changed. So let me try the math one more time. 0.02. Okay. And if there's still a holdup, if I don't get this right, then I will check it and post the correct version for you. Minus 0.02 times 1.27. Okay. I will double check my math for you because something does not look right. But once I do, I will post the correct answer here for you. All right, but everything down through 9 is okay. So I will double check problem 10 for you, and I'll make a note under it of what I found the case to be, okay? That is our final problem. That is going to be it for our course. I'm going to be writing our final quiz. Posting it, I'm not sure, probably anytime later this week. It will remain open until the weekend, okay? So you'll have plenty of time to try it, and in the meantime, if you do have any difficulties, make sure you communicate with me, all right? Thank you very, very much again for all of the efforts that you put in during this class. It was really interesting to see how this class translated to an all-online format, and the only thing that I can say about it, as different as it was to me, is that I feel that it worked out quite well based on what ultimately matters most in business, and that is results. Okay, you folks have returned great results. I look forward to your final quiz. If I can ever be of any assistance to you, please keep my contact information. I'd love to hear from you. And thank you again for your kind attention, and have yourselves a terrific summer. Bye-bye now.